Hello. Hello and welcome to this video on the last part of JSON functions and operators. We will finish the documentation in this series as well as in this video, as well as in the end I will show you a comprehensive example of all what we have discussed here. So let's get started. So we start from this note. In each variant of JSON table column described above, if the path clause is omitted, path expression $name is used where name is provided. Name is the provided column name. Then we have as JSON path. The optional JSON path name serves as an identifier of the provided path expression. The name must be unique and distinct from the column names. Error, empty, on error. The optional on error can be used to specify how to handle errors. When evaluating the top level path expression, use error. If you want the errors to be thrown and empty to return an empty table, that is a table containing 0 rows. Note that this clause does not affect the errors that occur when evaluating columns, for which the behavior depends on whether the on error clause is specified against a given constraint. Now we have an example. Let me see if video is recording audio. Yeah. So we have create table my films JSON, then we insert into this my films values. So you see that from here to here, it is one JSON stuff. So we have favorites and it's an array. Okay. And kind is comedy and films are title bananas, director Woody Allen, title dinner game, director Francis Survivor. Then we have horror films, title Psycho, director is Alfred Hitchcock, title thriller, film is Vertigo, title is Vertigo, and director is Alfred Hitchcock. Then we have drama kind films, title is Yojimbo, and director is Akira Kurosawa. Now we will extract value from all this. Okay, we'll do the query. The following query shows how to use JSON table to turn the JSON objects into the My Films table to a view containing columns for the keys, kind, title, and director contained in the original JSON along with an ordinality column. So we have select jt.star from My Films JSON table js, $favorites. So we are looking at favorites. There is this element star. It's an array, so we iterate over all the items, columns, ID for ordinality, kind text with kind text past $kind. So from favorites we go to kind and we pull out comedy, horror, and thriller and drama. Then we extract title text past $films star. We iterate and navigate further into title with wrapper, and then we iterate into director along with title. We have the similar behavior, director text path $films star dot director with wrapper as JT. So we have all this information in a tabular form. The following is a modified version of the above query to show the usage of passing arguments in the filter specified at the top JSON path expression and the various options for the individual columns. So here the change you see is for title, we omit the quote. You see, in the title, we are getting quotes here. Banana, the dinner game, Psycho, Vertigo, Yojimbo, we're getting title names. Here we won't get title names, but for directors, we are keeping the quotes. Okay, so we have the quotes here. Now see the filter here. Okay, $favorites. Now we iterate at all the films directed, and that should be equal to our filter. And we are passing Alfred Hitchcock as filter. So only movies directed by Alfred Hitchcock are selected by using this filter. Okay. And then we have columns, horror and psycho. The following is a modified version of the above query to show the usage of nested paths for populating title and director columns, illustrating how they are joined to the parent columns ID and kind. So again, we are using Alfred Hitchcock as filter, so only 2 movies will come. Now see, we select ID and kind, but for title and director, we have a nested path. So what we do is nested path $films star Now you see here the difference is once we have this nested path we have taken, we simply say dollar dot title or dollar dot director. We don't say dollar frame star dot title or dollar frame star dot director as we have done here. We simply say dollar dot title dollar dot director. So this is how we uh, traverse the nested elements, and we have the selection. The following is the same query but without the filter in the root path. So we don't have filters. So all will come. We have comedy, horror, thriller, drama, and the titles and the directors. The following shows another query using a different JSON object as input. It shows the union sibling join between nested paths $movie star and $book star, and also the use of for ordinality column at nested levels, column movie ID, book ID, and author ID. So here what we do is we have a favorites array and we have movies as the first element. Name is 1, that is John Doe, 2, name John Doe. Then we have book, name mystery, authors are Tom Dan, and then we have name wonder and authors are Jun Murakami. So here we select user ID for ordinality, so that will come here 1, 2, 3, 4. And we use nested $movies first and columns movie ID and name text path.name. So we are selecting movie ID from movies. Okay. So that is ordinality and $name. So it will take 1 and 2. So that will be selected, and then we do the same thing and director also we select here. Okay, with the nested path. So after movies, these are part of an array, and we can iterate after using $movie start and iterate all the elements in one level. Similarly, for books, we select and download that, select and put them in the JSON table, and we have our table here. So with this, we come to the end of JSON functions and operators. So this section is done, and now we will move on to sequence manipulation function in the next video. For now, we are not going through this. So as I said, I am presenting you this SQL example. So this is quite big actually. This is more than 1100 lines. So what I will do is that I'll show you some of it, and then I'll tell you what I'll do. So we create table customers, customer ID, name, email, profile, preferences. So it is serial primary key, name is text, not null, email is text, unique, not null, profile is JSON-B, preferences is JSON-B. So nothing is null here, all are not null. And we have product ID is serial primary key, details is JSON-B, not null. Then we have orders, order ID serial primary key, customer ID integer, references customer, so it's a foreign key, order data is JSON-B, not null. Then we have table order items, which contains order item ID, which is serial primary key, order ID references orders, and product ID references product. Quantity is an integer and metadata is JSON-B. Then we insert various data into these 4 tables. Okay, orders and order items. After insertion, we verify the inserted JSON by selecting customer ID profile from customers, product ID details from products, order data from orders. And we you can pretty print also and select JSON and JSON-B. So from here, the example really starts. So what I will do is I will put this as, I'll show some of it, and I'll put this as a gist from where you can download and practice. So my uh, table name is test, and we don't have any tables here. Okay, so we don't need to drop anything, and we create the table customers. We create table products and orders and order items. Then we insert customers, Alice, Bob, Charlie, which are our typical customers. Oops. So let me do this. Okay. And then we insert products. And then we have orders. And order items. So you can run this select query from customers, for example, it will always work. So we have this data which we have inserted. Now we can pretty print JSON by selecting details from products. So it will print us JSON in pretty format. Now we can select to JSON as JSON JSON value and to JSON JSON value. So this is an example to differentiate JSON and JSON. We are selecting now, which is the timestamp, and we have the same timestamp for both. Then we can use JSON build from SQL values. So we are selecting server, version, current database function, and today is the current date. So server is version, current database is current database, today is the current date. If we select that, our server is PostgreSQL 18.4 running on Debian, compiled by GCC and all that. Current database is test. Today is 2026, 30th July. Now we can build more JSON objects here. So product is 350, 350 here, and SSD product is SSD. Price is 350 and capacity is 4 terabyte. You can build JSON array like so, and you can build JSON B arrays as well. So I would suggest that you execute these queries and look at the result and try to understand that what is going on. I will not be able to go through all the examples. So now we are referring to customer ID, that is customers table. So we are looking at customer ID 1 and we are converting row to JSON. Okay. So from customer C row to JSON C, and we have Alice as the customer because the ID is 1. So if we give ID 2, Bob should come, and for ID 3, Charlie should come. Okay. So we have the full information, go to JSON, and then we extract specs from the details column of products. So the column name would be specs, and we are extracting the specs of details. Now if you select details, then you will see what are the details here. So these were the details, but we extracted spec. Okay. So spec for this was from here to here. All right. And specs for the second row was from here to here. Okay. Now we can extract text using single arrow, double arrow. So we select product ID, name, and brand, and all that. So we have that. Okay. So we can go ahead and practice this, and then we have nested extraction and so on. So let me put this as a gist, and I will name it XML. I will name it SQL JSON.md, gist.github.com, and we call it SQL underscore JSON.md, and we put 3 ticks SQL, and then we paste it, and at the end we put Google the backticks, and we look at preview. Yep. So go ahead and practice it, and if you find any problem, let me know, and I should be able to help you with the problem which you have. The link to this gist will be in the description of the video. So you can click that link and uh, copy this or download this and play with it in PostgreSQL. So if now let me again open that PostgreSQL. So we will study sequence manipulation functions in next video onward. Okay. So I thank you for watching the video, and I hope that you enjoyed and learned something in this video. So I'm finally happy that we are through to the longest section of the PostgreSQL. I expect it to be the longest uh, sections at 3 pages, quite a bit of information we have covered. So we will meet again tomorrow and we will study sequence manipulation functions which are created by the serial keys and those things. Okay. So whenever you create a serial column, these sequences are created. Okay. As you can see, sequence generators. Okay. Sequence objects are which create sequence. So whenever you create serial columns, these sequences are created in PostgreSQL. So I thank you for watching the video and we will meet again tomorrow. Till then, stay curious, keep learning, and most importantly, enjoy.